special functions. Today's special function is going to be the absolute value function. So as you can see from this example that I've given you, we're looking at the function as being the absolute value of x plus 1. So in this function, you can see when graphed, you get this V-shaped. Now the reason that V-shape occurs is because you're taking the absolute value of numbers, which takes any of those negative values and makes them positive. So let's look at what the parent function to the absolute value looks like. So that when I talk about the parent function, that's the function that has no addition, subtraction, multiplication, or division in it. So our very basic function, or our parent function, is the absolute value of x. So what I'm going to do is just plot some points, the old-fashioned way of graphing, and find where they end up. So if I pick, let's just go right around the origin, -2, and I want to take the absolute value of that, that's going to become +2. -1, taken the absolute value of, becomes +1. 0 stays 0, the absolute value of 1 is 1, and the absolute value of 2 is 2. So when I plot these on the graph, normally if I would just graph y equals x, that identity line, we would get that diagonal line. But when I put those absolute values on that function, what it's going to do is take all of these negative values and revert and make them positive. And that's where we get our V shape. So let me just do that by plotting these 5 points. So these 5 points give me -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. And there gives us our parent function of the absolute value. So we get that V-shaped. Now when I look at the domain, now we've got that continuous function again, which is different from our greatest integer function. We have that continuous function again. So my domain is going to be all real values. That seems to be the trend. And our range now is going to have values that don't exist in this vertical area. So my range is going to be y values such that y is always greater than or equal to 0. That is our first absolute value function. Now let's look what happens when we add addition and subtraction into our functions. So we're going to graph 2 of these side by side so you can see what's actually happening here. So the first function is asking us to graph the absolute value of x minus 3, with the -3 being on the inside. When it's on the inside, I'm going to do that first before I take the absolute value. So I'm going to set up my values, x, and then I'm going to subtract 3 from them, and then I'm going to take the absolute value. So this is a little similar to how we set up our greatest integer functions. All right, so when I'm plotting our points here, I can start at -2, -1, 0, 1, and 2 and see what happens here. So I'm going to subtract 3 from each one of these 5 values, and that's going to give me -5, -4, -3, -2, and that last one's going to give me a -1. Then what I'm going to do is I'm going to take the absolute value of all of those. So I can see 5, 4, 3, 2, 1. Now when I begin to graph these, I notice that -2, 5, -1, 4, 0, 3, 1, 2, 2, 1 didn't give me that V shape that I'm looking for. And that's because that subtraction of 3 inside is moving that V around. It's translating. So I'm going to have to continue picking a couple more points until I find where it is that my graph starts to head in the other direction. So I'm going to go to 3. 3 minus 3 is giving me 0. So I haven't started back up the other side yet. So 4 minus 3 gives me 1, and there it is. 4, 1, and now I'm going to start making my way back up. 5 minus 3 is 2, and the absolute value of 2 is 2. So I can continue that trend knowing that I found where that V is located. So let's talk about the domain and range of this function. The domain is, again, all reals. And the range, again, is starting at 0 and going up from there. So it's all y values such that y is greater than or equal to 0. All right, notice that if I compare this graph to the parent function, that it's taken the parent function and actually sliding it to the right by 3 units. That's what that minus 3 on the inside does. It's actually going to move the graph to the right 3 units. Now, let's compare what happens if I put a plus 2 on the outside and if that change does what we think it will do. All right, now, because the absolute value comes before the addition, I'm going to plug a value in for my x. I'm going to take the absolute value, and then I'm going to add 2. All right, so I'm going to start with those same 5 points. I like to start there and see where I need to go. Eventually, we're going to be able to see maybe where a better starting point would be. So I'm going to take those 5 points, and the first thing I'm going to do is absolute value them. So they're all going to become positive values. Now I'm going to add 2. So that becomes 4, that becomes 3, 2, 3, and 4. So you can see that I'm going down and heading back up, which means that I don't have to extend my graph any further because I'm going to find that V right away. So now I'm going to plot those points. So negative 2 is going to go up to 4, negative 1 up to 3, 0 is going to go to 2, 1 is going to go back up to 3. You can see that it's starting to make that V shape, and 2 is going to go up to 4. So the blue graph that I have previously graphed on there is my f of x function with the absolute value of x minus 3. But the red graph is my g of x function with the absolute value of x plus 2. Now, if I compare that red function back with that parent function, this one's always hard to see in that green. If I compare it, you can see that it has been moved up 2 units. And that's because of that plus 2 on the outside. It translates the entire graph up 2 units. So we're going to start talking a little bit more as we work on these functions about what happens with the translations and moving of graphs. All right, let's look at our last example. So you notice that our last example has both multiplication and an addition problem in it. So it's got 2 operations in addition to having that absolute value function. So I'm going to have a lot going on when I graph this. So I'm going to start with x. Let me kind of slide this guy out of the way for a minute. Now I'm going to use my order of operations, so I should add 2 to the x first because that comes inside. Treat those absolute values as parentheses. Then I'm going to take the absolute value of x plus 2. And the last thing I'm going to do is I'm going to multiply all of those values by 3. So this is a little bit of a longer process because I have an extra operator in there. And again, I'm going to start with those points. And you see that I always leave space in case I didn't pick a good 5 points to start with. All right, now add 2 to all of my values. So that's going to be 0. That's going to be 1. 2, 3, 4. Now, as I'm analyzing this, I see that I'm going up, 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 up. but I'm not having a V where I went down and back up. So if I continue going to the right, I'm probably just continuing to add and looking at just that linear shape. So I'm going to move to the left and see what happens this time. So negative 3 plus 2 gives me negative 1. Negative 4 plus 2 is going to give me a negative 2, and that's really what I needed so that when I take the absolute value, these are going to become positive, and you're going to see the graph going down to 0 and then head back up. So now let's go to step 2 and take the absolute value of all of those numbers. So I'm going to go ahead and make them all positive. And now I'm going to do the last operation, and the last operation was to multiply everything by 3. So that 2 is going to become a 6, a 2, a 0. Oh, that's not a 2, is it? That 2 should be a 3. 0, 3, 6, 9, and 12. So I really don't need this stuff anymore. If that's too much, kind of shade that out of your way and look at the ordered pairs that we have that we're building. Negative 4 is going to go to 6. 1, 2, 3, 4, 5, 6. Negative 3 is going to go to 3. 1, 2, 3. Negative 2 is going to go to 0. Negative 1 is going up to 3. 0 is going up to 6, and you can see that it's just going to go up by 3s from there. So I get a really sharp V shape this time. Whoops, I missed that, didn't I? Let me try to catch that a little better. All right, so when I have that absolute value, now if I go back to that parent graph, again, there's my parent graph, you can see that my new graph is much skinnier. So what happens is that 3 makes it skinnier. What it's mathematically doing is it's stretching my graph vertically. And then that plus 2 on the inside is actually taking it from where it started and moving it to the left too. So once you start to identify where your graph's going to end up, it's going to make it easier for you to pick those initial values. All right, the last thing we need to take care of is our domain and range. And my domain, again, is going to continue to have all real values as its set of numbers. But my range this time, again, it starts at 0, so it's all y values such that y is greater than or equal to 0. All right, that concludes our 3-part lesson on special functions with understanding how to graph the absolute value function. Please look for your assignment on Google Classroom. Have a great day.